Okay, hello, the students of the group 211 again. Today is the 13th of November 2020. So now we have the fourth lesson, the lecture, the 18th lesson. Okay, the lecture. So the lecture. Let us open the Moodle. So our previous lesson, the laboratory work, statical and dynamical object. First we compare statical and dynamical structure like we did in some of our previous laboratory works. So how we create dynamical structure? So first we create the pointer. After this we dynamically, with the help of new, create the structure and use it with the help of the pointer and the operator arrow. Okay, so the same situation with classes. So now we compare statical class or statical object and dynamical object. So the declaration is the same, the realization of methods is the same. It is no matter how you create the object statically or dynamically. So here I have the difference. Okay, but it depends on your own device which you use. Okay, so the visualization depends on your device. Okay, so there are special methods to for universal visualization. It is called alignment. Sorry, not alignment, layout. Okay, but here I have a custom alignment. Okay, so it must be rearranged. Okay, but not now. Okay, so in the case of dynamical class, first it is necessary to create the pointer, like in the case of the structure. So first we created the pointer. After this, it is necessary to dynamically, with the help of new operator, to create the structure. Okay, so in the case of the class, first it is necessary to create dynamically the structure. Okay, so and after this, it is possible to use and to give the address to the created pointer, and to use the pointer and arrow operator like in the case of the structure, the pointer and the arrow operator to obtain the elements, the members of the structure, the fields. Okay, so and here it is possible to use the pointer, yes, and arrow operator to obtain the methods and the field, for example, x. Yes, so here we create the second object dynamically, yes, but here we created two statical objects at the very beginning of the executing, but here we created dynamically first object and secondly second object dynamical, and use with the help of proper pointer. Here we use with the help of objects and dot operator with the help of pointers and arrow operators. Okay, so and the cycle. So instead of the statical object and dot operator, so is use the pointer and arrow operator. Okay, so this is how to create classes, objects of classes dynamic class. This name may be used, or statical class. Okay, so this is about our previous lesson, the third lesson. So the first lesson was absent today in your group, but the third lesson was laboratory work. Okay, so now we have the fourth lesson today, the lecture, the 18th lesson. So, and let us go to our course and let us on the addition mode, the mode of addition, режим редактирования, режим, the mode редактирования of addition mode. Okay, so after this, let us add the next topic. It was Тема 7, topic 7, so now topic 8. So, and let us add a new page. So, lecture 9, so today will be lecture 10. Lecture 9 was class and object. Okay, so today we have lecture 10. Let us add the page. Страница page. Okay, the page, HTML page. Okay, lecture 10. Lecture 10, which lecture 10? So, heritage principle. Heritage. So, why heritage? Because this is a programming. It is not the relations between people, but in C++, this principle of heritage is the second principle, the second main principle of modern programming. So the heritage is the second main principle of modern programming. Okay, so what we do now? So let us return to our previous page. And let us go to the forum. Okay, let us open our laboratory work and let us take the not the structure but the class, statical class, statical object. Let us take only statical. Sorry, so but only statical. So press Ctrl C. So let us go this place and let us paste. Okay. So here is the statical class creation. So it's in class, it is no matter which class we have, statical or dynamical, simply class. New inclusion, okay, let it be new inclusion, but this inclusion is not visible in GDB Online compiler. So new inclusion, if we press run now, so let us remove the comment. If we press run, yes, so the compiler does not understand what does it mean Windows H. So in addition, C++ language must be selected in this case. So C is over. So the class is absent in C. So let us return to C. Let us press run. Window again. Okay. So let us comment window, and in the frames of C language, let us try to compile class. Press run. Yes. So class is absent. Class is absent in C. Okay, so let us return C++. So let us press run again. Yes, so this mistake is absent. So class appears only in C++. Okay, in the C++ means the development of C. Okay, so but we have a lot of mistakes, so I tried previous time to compile this program online, and I find a lot of mistakes. So before to use this program GDB compiler, it is necessary for me to check. So when I will check, so I will list you the I will give you the list of fixings, yes, how to fix this program to GDB, yes, and after this, the task will be to compile in GDB the statical class and to compile the dynamical class and to send me the results, the photo of compilation. Okay, so let us return to our today's work. Okay, so the lecture. Yes, the lecture, the heritage, lecture 10. Okay, heritage. Okay, so let us imagine. Okay, so declaration of the class. Now let us indicate which class. C point. Declaration of the class C point. Let us imagine that we have a lot of work. So first it is necessary to emulate the motion of the point. So let us go to the Microsoft Visual C++ 6.0. So I created previous lesson. So in laboratory work, today's laboratory work, the dynamical class. So instead of to create the objects, I create two pointers. Instead of to create statically, I use new and create first object dynamically. After this, I create a second object dynamically. So I use the pointer to give to this pointer the address which is returned by new operator, the address of the proper class, proper object, I'm sorry. And after this, it is possible, I show you again, so to use the arrow operator after the name of the pointer which receives the address of created class. So now the pointer and the help window will appear. Okay, so you see all the members of the class. So hide, just click twice. Yes, it's possible. So in this way it is possible to use. So the result of this compilation is the same as yesterday. Okay, so let us compile. Yes, let us build. Yes, and let us execute. So the result. So, and after this we have the cycle of emulation of motion. Okay, so this is the first point, this is the second point, the second object, but they are now created dynamically. Okay, but result will be the same. So visible result is the same, but the using of memory is different. So in statical creation, the memory is used one more time in the beginning and removed in the end, only in the end. But in dynamical, so the memory is filled during the execution, so first by the first object and later for the second object, okay, dynamical object, and removed dynamically too, not in the very end. So it is possible to use delete, for example, operator. So, but now I press the key and you will see the emulation of the motion of the first point. Okay, so any key. What is wrong? Yes. Yes, very well. Okay. So the result, visible result, is the same as in previous lessons. So let us return to Microsoft Visual Studio in the CPP file. Our CPP file dynamic project is called dynamical class. So dynamical class CPP. So let us see file view. So the files of dynamical class project. So the source file dynamical class CPP. Here is this file. External dependencies. What is external dependence? Okay, it is no matter which external dependence we have. Okay, so this. So the problem is now we emulate, as you saw, just emulated the motion of one point or 2 points. But for example, our task is very complicated. How to emulate not only the motion of the point, but emulation of other for example, bodies, for example, of emulation of the circle. Yes, what is necessary to emulate the circle? It is necessary to radius of the circle, to color, for example, of the circle, and the coordinates of the center of the circle. The coordinates of the center of the circle. So what? So the declaration of the class. Okay, so of the class. Let us. It is better. Yes, it is better to copy this. Press Ctrl A, press Ctrl C, and to create the next project. So let us close the space. Yes, and let us create a new project. New. So console application. So heritage in two classes. In two classes. Let us. It's better to repeat. Okay, so press OK. Into project. Yes, heritage in two classes. So project and project. New source file. So the same name. Heritage in two classes. Press OK. Yes, and let us insert here our listing, our text of our program. I'm sorry. Okay. So declaration of the class C point. Yes. So after this realization of methods of the class C point. Okay, but now our task is more complicated. How to emulate in one program the motion of one body, the point, and the second body, different body, the circle. Okay, so we saw that to emulate the circle, it is necessary to indicate the radius, the color, and the coordinates of the center. But these fields are presented in the class C point. Yes, and to emulate the circle, it is necessary the function height, to the function show, and the function move. Okay, so what is the conclusion? So let me open the listing of this second program. So now I will open the book with the explanation but in Russian, so it must be translated in English. So part 2, the programs written in C language to programs created in Visual C++. Visual, it is not now the visual, because we work in textual mode, as we saw. The visualization is absent now, but we, after some time, short time, will create the windows, so the visual C++. Okay, but visual, it is not exactly to create the programs for operational system with pictures, yes, but Visual C++ is possible to use. Okay, so, but now it is just C++. Okay, so what we have to do? We have to use two emulations in one program. Two emulators. First emulator, the emulator of the motion of the point, and the second, the emulation of the circle. Okay, so the methods must be the same. Okay, so the fields must be the same. So what is the conclusion? So after the declaration of the class point, after the realization of their methods, before executing part, it is necessary to insert the declaration and the realization of methods of the next second class of our program. Okay, so you see this is the white program, so with two classes. So declaration of the second class of the circle, class circle, C circle. Okay, and the realization of the methods. It's after some time. The class C circle. Yes. Okay, but let us use the declaration of the class C point, or even it is better to put here class C circle and declaration. So the block of declaration. This is a prototype of the class. Yes, and declaration, and after declaration, in comparison with functions, so the functions, the declaration of function is just a block, but the declaration of class, it is the declaration of new type, so must be accompanied necessarily by the semicolon, like in the operator. Okay. So like in the structure, for example, so let us see again. So these are two classes. So the end of class declaration must be necessarily put it semicolon, and in the declaration of the structure must be put it semicolon 2 after the declaration of the structure. Yes. Okay, so let us return to the the declaration of classes, the same situation. Okay, so and let us go to Microsoft Visual C++ 6.0. Okay, so the second class, C circle, what is necessary? It is necessary to put here the fields, the same fields. Okay, but these are the other fields. These are the fields of class C circle. Okay, so these fields are public. So what does it mean public? Public, it is possible to use in other classes. Okay. So, and the declaration of methods. The declaration of methods. So first, which method must be put on necessarily? Okay, the constructor of the class. C-circle constructor, C-circle. The name of this constructor coincides with the name of the class. Necessary. C-circle. So, C-circle and the parameters. So the parameters may be the same as in the case of C point. Okay, so the initial values of the fields. Okay, the destructor accompanied with tilde C-circle. The destructor, the declaration, oh, I'm sorry, so this is a declaration, so semicolon is necessary. Okay, and this functions hide, show, and move. But for the C-circle. Yes. Show and move. Okay, so but let us try to analyze this situation. So again, it is necessary to realize the constructor, the destructor, the hide, the show, and the move. Okay, what we did in constructor. So we initialized the initial values of our parameters. Where is it? The constructor. Yes, here is the constructor. Okay, so let us copy the constructor. So this, let us copy this. The block. So what it is necessary to put here? Instead of C point, it is necessary to put C circle. Circle. This double colon and the name of the constructor. So constructor is absent in this list because constructor must be put it anyway, so defaultly. So it is not necessary to help you anytime. Okay, so the name of constructor is coincides with the name of the class. So this is the name of the class, this is the name of the constructor, the same. C-circle and the parameters. So I put here the block and the parameters. Okay, and no semicolon because after this is the headline function in realization. After this will be the block. Okay. Okay, the constructor. Okay, the destructor in which we put all this to 0. Okay, so first the name of the class C-circle, double colon, yes, and the destructor. The destructor, realization of the destructor. Let the realization of the destructor be the same. So we put all the fields to the 0. The fields or the data, the fields. Okay. Very well, the destructor. Okay, so now it is necessary to realize the hide, show, and the move. So, but instead of point off, it is necessary to put the circle off, the circle on, and yes, so let us take hide, let us put it here, yes, and let us remember that here we must put circle, so circle. Let it be point. So the same situation is with show function. So let us insert here this, and let us put. Let us imagine that we put here circle. Okay. So and let us take a move from this place and to put the move. Yes. So now we declared the second class. We realized the methods of this second class. Yes. And it is possible to use to create the here we create the pointers to create the objects, for example, of second class. But do you see? Okay, do you see we have a lot of lines? Our program is very, very big. So, the declaration of the first class, the realization of 5 methods, the declaration of the second class, the realization of 5 methods of this takes a lot of space. So, but the actions are the same. The actions are the same. So for this purpose, what is used for this purpose? Okay, so let us return to our module. Okay, to today's topic. It is used. The heritage is used. The heritage principle is used. What does it mean, heritage? Heritage means that in the case when we have 2 classes with the similar actions performed, with the similar purpose. So the first class, C point, emulates the motion of the point. So the second class, C circle, emulates the motion of the circle. But the purpose is the same, to emulate the motion of geometric bodies, the point and the circle. So we use the same fields. Yes, we use the same methods. We use the same function move. Okay, so we have difference in where we have difference. Here we have difference. So point and point. Okay, point off, point on. In hide and show. But move coincides completely. Move coincides completely. Here we must put, instead of point, we must put circle off and circle on. But move coincides completely first. The fields coincides completely. Yes. So only hide and show differ. Hide and show differ. So here in the first class, we have point off and point on, respectively. In hide, point off, and show, point on. So here, let us put. So in the circle, here, circle off, and circle on. So these methods differ, circle on. But the names are the same, hide and show here and hide and show here. The structure of the class is the same, but the methods differ. Okay, but move coincides completely. So X, Y, RC coincides completely. Okay, so for this purpose, what is used? The heritage principle is used. The second principle. So first principle is encapsulation. The second is heritage. Okay. So how to use the heritage? That the methods and variables of one class are available in other class. Okay, for this purpose, this class must be heritaged from the first class. So in other words, without any heritage. So this is a basical class. Yes, the base class C point, and this class is the deriving class from basical. Okay, how to put here that this class is derived, is heritage from this class, from base class. Okay, how to put here that C circle derived is derived from class C point. Okay, so let us see my book. Let us see my book. Okay, so after the name of second class, which must be derived from the basical class, okay, so must be put the colon, and after the colon must be put it. So which components of the first class this class may use? So public components. So all these components, public C point. What does it mean? That class C circle is derived from the C point and may use public components. Their public components. Not all components of the class, not all members of the class may be public. So instead of public, there are some keywords. For example, private and other. So now we have public. Okay. So what does it mean? How after this, how we may simplify this class? So in this heritage, so it is not necessary to repeat all the fields. All the fields are heritage automatically, like we automatically call the constructor when we create the object. So in heritage, automatically all the fields may be heritage, so it is not necessary. So the fields heritage automatically. Heritage automatically. From basical class, default, automatic. Okay, so it is not necessary to repeat. So instead of to put here x, r, x, y, r, c, so it is necessary to put only that this class is public C point. So this is derived from the basical class public. Okay, basical class, I'm sorry, not public, but C uses there its public component. So the constructor must be put it obviously. But in the realization of constructor, it is necessary to indicate that this constructor is after the colon, the name of the constructor of basical class, because when we create the object of C circle, so not only the constructor C circle will be called automatically, but the constructor of basical class will called automatically. Yes. Called automatically. So this is C++ language created by Bjarne Stroustrup. This is a feature. So when we create the object of derived class, so not only the constructor of this class is called, but the constructor of the basical class 2. So it is necessary in this case to indicate necessarily the constructor of basical class C point, and to put here without explanation only the list without the creation. So we create it here, yes, but here it is necessary only to list without any additional creation. X, the parameters y, r, and I see the parameters of the constructor basic class. Yes, only to list parameters of constructor. Yes. So, but it is not necessary because this constructor is called automatically, so it is not necessary to repeat one more time the sections. So simply the headline, so without no repetition, but here we must realize, so it is possible to put this, yes, so the computer is empty, yes, the computer is empty, so, but this, the constructor is empty, but this constructor is called automatically, and in this constructor we have the information that automatically must be called the previous constructor, the basic class. So this is a realization of the constructor of this circle. Yes, so you see that it is not necessary to repeat one more time the same actions. Not this, but this. Because the actions are the same, so only to use this. Yes, so it means that constructor so uses the same parameters, yes, but how to use these parameters? So here we will put, but not here, not here, not in C point, not in C point, yes, but we put the parameters in C circle, yes, but after this will be called the C point and uses the parameters of C circle. Okay, so it uses the parameters of C circle. Very well. Okay. So in this case, I am not sure that the parameters of the basic class constructor must always coincide with the parameters of heritage, of the parameters of the derived class constructor. I'm not sure, so if you interested in this question, so please find the information in the internet, so maybe read the attached handbook by Herbert Schild, for example, in some, okay, not now, okay, in some previous lessons I attached you in новостной forum, in forum of news, in some place I attached you the link to the book of C. Okay, but it is not C. No. It is must be considered the book handbook on C++. But Herbert Schild. Yes, Herbert Schild C++, handbook in C++. So you may try to find if the parameters of derived class must coincide necessarily with the parameters of basic class or not. So anyway, so this is the realization of the constructor. So the destructor, okay, so the destructor so must be realized in different way, Okay, so let us put again double, okay, no synaps, okay, yes, So the class view. Okay, so two classes appears. Yes, globals, main global function. Okay, not the function of any class. Okay, so and the members of one, the members of. Okay, so the basic class is the down class, Okay, so this is circle. Okay, so the constructor, the destructor. Okay, so the destructor must be realized in its own way. Okay, in comparison with constructor. Okay, so here circle and hide and show. Okay, so in the case of heritage, in the case when one class is derived from another class, so it must have the some methods, some same methods, but these methods must be declared virtual methods, which method are virtual. So the hide and show. So here we have hide and show 2 in the case of circle, hide and show 2. So in this case, in heritage, in two classes of one hierarchy, so this is the top of the hierarchy, this is the second class of the hierarchy. This class is basically the base of hierarchy. This is the second class, the derived. So when they have the same methods, the names are same and the list is the same. So in this, the name is the same at least. So we must declare this function virtual. So here must be put it virtual. After void is this virtual hide and void virtual show virtual. Yes, because virtual. Because do you see that the members of one class are derived in other class? So and the fields are heritage automatically. So and the move function is heritage automatically. So it is not necessary to put here move. Okay, so the move is completely the same. So it is, let us remove this move. Okay, because move will be derived automatically like fields. So, but these two functions are not the same. So, if we put here not virtual, so we derive in this class this function automatically. But here we have point, and in hide and in show we have point. But we must have the same functions with circles. So they are different functions, but with the same names, with the same list of parameters. So in this case, it is necessary to recover the heritage of this function, to put the keyword virtual. So it is function virtual. Yes, and here must be put it the same functions, but virtual too or not. Let me see. Yes, virtual and virtual. Yes, virtual and virtual. Virtual. Yes. And virtual. Very well. Okay, so virtual, but here must be added maybe virtual or not. In in my listing, so the virtual is absent. In realization, the virtual is absent, so it is only indicated in declaration. Okay, virtual. Yes, so after this, we have this class. So only the constructor, the destructor, and two virtual functions. So the names are the same, yes, but the content of this function different. Yes, here we have point and here we have circle. Okay, so that's all. Function move is derived automatically. So move is derived automatically. It is not necessary to repeat the declaration and to repeat the all which we don't repeat, so are heritaged automatically. Okay, so we don't repeat we did not repeat the fields, and we did not repeat move. So the fields and the move, the fields are heritaged anyway automatically, and move to. Okay. And move to is derived automatically. So instead of to put here the fields, put here move, yes, we must only put the constructor, the destructor if it is necessary, okay, and the virtual function must be repeated. Obviously the names are the same, but the content is different. The content different. Okay. So how to use? So in this previous demonstration, so we created dynamically. Okay, so let us go to the laboratory work. Sorry, something wrong. Yes, let us go to laboratory work. Yes, and let us take the statical class, not dynamical. For the clearance, let us take statical. Okay, so this statical, yes, and statical to the end. And let us put to our program statical. So let us create statically, not dynamically, but statically. So from here, okay, until the end, just put the statical creation. Okay, statical creation. So okay, let's return. Instead of to create two objects, let us create one object. Is only one object. Yes, only one object. It is enough. It is enough for the purposes of our today's lecture. So statical object is not necessary to indicate that this is statical object. Simply the creation of object of class C. Yes, to create the object of class C point. So using the members of the class C. add move show and etc. It is not necessary to explain all these features. Yes, so now it is possible to create the object of class C-circle. Maybe here, maybe after the creation and using of the class, maybe after the working with the class C point, it is better to create the object of C circle. Maybe it is better to create here. Okay, let us create here the object of C circle. Okay, for example, my circle. Let be the name. Okay, so the parameters of constructor, so the coordinates of the center, for example, 43 and pixels, 43 pixels left, and from the top, for example, 12 pixels to the center. Okay, so the radius of the circle, for example, 10. Okay, and the color, for example, number 4. Which color will be number 4? For example, the red will be number 4, the 5 maybe the blue. It depends on your purpose. Okay. Okay, creation of object of the class C point. Creation of the object of the class C circle. Yes. Object. A using of members of the class C point with the help of the object main point. So the same using of members of the class C circle. Let us copy this. Let us put it here. Using of members of the class C circle. Okay, so what we have to change? So instead of my point, to put a circle. So let us press here again the dot operator. Must the helping window must appear with the members of my circle. Yes, do you see the members of my circle is the move C, R, X, Y, not only hide and show and the destructor, but the destructor of C point too. Okay, so please see what we heritage. So defaultly we heritage all these methods, this destructor, this move function. Yes, yes, we heritage. We would not. It is not necessary. It is the declaration of this members are the declarations are absent. Okay, here, but when we use the object, so first it is necessary to create my circle. Let us repeat this. My circle, let us press the dot again. Okay, so we see that X, Y, R, C are visible in my circle. Okay, and even the destructor of C point and the move. Okay. So hide and show virtual functions and the destructor. So do you see this lock? So these functions are the functions. Okay, so it indicates the members. Okay, so hide, show, and the destructor. The constructor is used by us where it is used. It's just used. So when we create, so the constructor is not necessary to put here. Okay. So the methods of the class, so the destructor, the hide and the show, okay, are presented now. It is possible to obtain this method. So the first is hide. Yes, hide. Yes, the second is move, but my circle. Let us repeat again. Okay. Move is possible to use with the help of my circle. So my circle, of my circle. So if we put here my point, move, so what changes? So it is very interesting question. So move is the same, but what happens if we put here my point move? My point move. Okay, so let us first put here my circle move. Okay, and after this, in the future, we will compare. What happens if we put here my point? Okay. So, okay, so let us put here my point. Move. So the move, yes, the parameters. So it is better to change the parameters to see the difference. Okay, but now let us not save, not change the parameters. Well, maybe it is better to change the parameters. Okay, so let us change the parameters. So for example, 3, for example, 1, the radius grows in 3, and the what is and the color and the decrement of colors, for example, 2, color grows in 2, so before and after this will be 6. Okay, and my circle show what happens if we put here my point. So nothing happens. So show will be the same as hide. So, but now show will have not the same. So in hide, I'm sorry, we have hide the message off, so off. In show we have a message on, but the parameters, the values. So if you put here my point move, so nothing happens in show. Okay, but if we put here my circle move, not my point move, but my circle move, in show we will have the other parameters. Okay, so let us put here show again. Yes, show. Yes. And my circle x from my circle. But x from my circle is the same as x in my point. Yes. It is the same. Okay, here we have the demonstration of my point cycle. Okay, so let us stop and let us compile. Okay, very well, 10 errors, very beautiful. Okay. function void key point height. What is room? So already has a body. Already has a body. What does it mean? Void key point already has a body. Function void this call key point height. Void already has a body. Key point. I'm sorry. What is this? No. Let us return. Okay. Space. Okay. Already has a body. Already has the body. What is wrong? Yes. So we just copy. So here, yes, already has the body. It is true. So C point height, C point show. So here we must change the class C-circle. Yes, C-circle and yes. Very interesting mistake. C-circle. Yes. C-point. C-circle. Okay, let us count 4 errors. Okay, which errors? Circle, my circle. Circle, what is wrong? Cannot access private member declared in class C-circle. Maybe it is missed the keyword public. Okay, let me see the listing. Yes, the public is missed. So if we miss the public, yes, it is not possible to use the members. Okay, so it is necessary to put here public. Public is missed. Yes, it is the mistake. Okay. 0 error, 0 it's okay. Mistake. Execution. Okay, so let us see the result. Okay, point off and circle off. Yes, so the last value of x. The last value of x is 36. Circle off and point off. Okay, so let us put here one more space in height of point and in circle of the point. Or it is possible to remain the same, to remain the same. So 43, 12, 10, and 4. Okay, so let us check. Let us return. Okay, let us return to our listing and let us check what we must obtain in the screen. Okay, so these are parameters 43, 12, 10, and 4. Okay, so it must be in the height function. Okay, let us execute again. Sorry, it is not execution, it is translation to the next program. Let us execute again. Okay, so let us check. Yes, 43, 12, 10, and 4. No, my program treated the created exe file as a true. My antivirus program. Okay. So what must happen after this? 46, 13, 13, 6. Okay, so let us go to the Visual Not Visual, Microsoft, yes, Visual C++ 6.0. Okay, so let us check. Okay, so 43 plus 3 is 46. 12 plus 1 is 13. 10 plus 3, 13 again. Very interesting. And 4 plus 2 is 6. So 46, 13, 13, and 6. Okay, let us return to compilation result. One more time. Yes. 46, 13, 46, 13, 13, and 6. Yes. And x, the last value of x is 36. But if we put here I from C point must appear 25 again. Okay, so let us try. Okay, so instead of my circle x, let us try to put here my point x, and let us see whether it changes or not, or maybe it is the same x. Okay, as yes, so it changes to 25 or not, or remains 46. Okay, so whether the x is the same in two classes or this is the different. Okay, so let us start. Yes, let us start and let us see, let us check. Yes, do you see that x in the class C point is not the same as x in the class C circle. So this is only how to perform the economy of the code of the program. But these fields have only the same names in the same time. But these are not the same. These variables will be other variables. So other place in memory is created. So when we put here my circle, so we will return 46. Circle. Okay. So let us compile this. While let us build, let us execute, and let me show you the result. Okay, 46. So the x from C point not the same as the x in C circle. Okay, so how this functions? Okay, so if we put here the move and the move, but this is the move of my point and this is the move of my circle. What happens if we put here the move of so now we have 43 plus 3, 46, 12 plus 1, 13, 10 plus 3, 13, and 4 plus 2, 6. So 36, 13, 13, 6. Yes, so let us compile it. Okay. Something wrong, one more time. Okay, one more time, yes. Okay. 46, 13, 13, 6. Yes, but let us put here the move function. Okay, so let us stop. Okay, so let us put here the move from my point. What happens? Sorry, try again. Treats the exe file of this project heritage in two classes. So when I execute, so in debug, so let us open in debug appears the, let's open all the files. The exe file, but what is this? No. So it is necessary to, sorry, debug. Yes, so the class, which class? Dynamic class. Which dynamic class? Heritage. Heritage. Where is heritage? Heritage. Heritage is heritage in two classes. Okay, let us open debug. Okay, heritage in two classes exe. It is possible to start just from this folder. Heritage in two classes exe. Okay, so but my antivirus treated this heritage in two classes exe like a virus, like a Trojan. Okay, so yes, we change here move. Nothing happens, so the parameters which 43, 12, 10, 4 in height must be the same in show. Let us check. In this case, when nothing to move. Okay, so when we move the first point, but not the second. Okay. Result, let us see. Yes, nothing happens. Okay, and remains 43. I remains X remains 43. Okay, very well. Okay, so yes, very well. Okay, so here you see the very interesting situation that we have hide and show function in one class and the same function in other class C circle. So this is the third principle. Third principle. The third principle is the polymorphism. Polymorphism. Okay. Polymorphism. So what does it mean? Morph, it is the Greek word which means the form. So poly, it means many, so many forms. So please see the hide and move again. So my circle. Okay, so let us return my circle. Return my circle and let be sure that the parameters will change in this case. The parameter, okay, so yes, Trojan in heritage in two classes debug. So this program exe, the name Trojan generic. So yes, so обнаружены и перехвачены троянские атаки. So detected and catched Trojan attacks. Okay, so the program, yes, very well. Okay, so yes, and antivirus proposes me now to check. Okay, so now I close and now I continue. Okay, I continue. Yes, so we have hide and move in class in object my point, and we have hide and move in object my circle. Okay, so we have hide and move in the class C point here. It is better to see in declaration. Hide and show. I'm sorry, not move. Hide and show in the class, and move to hide, show, and move. Okay, so in the class C point, and we have the same functions and hide. Sorry, I'm sorry. So hide, show, and move, and the fields, the same fields in the class C circle. Yes, but we saw that the x in my point does not coincide with x with in my circle, and hide and show in my point don't coincide with hide and show in my circle, because here class is 20, here x is 25, there x is 46. So let us compare. Let us see again. Yes, 25, 46. So height function in C point. So the function with the record point off. So the height function in C circle, the function with circle off. So the show in C point on, the show in C circle on. So these are different, and the move function is different. So here we have motion in 5, so here we have motion in 3, so here we have motion in -2, here we have motion in +1, so here we have motion in 0, here we have motion in 3, so here we have motion in 0, here we have motion in 2. So the move function is different. So in point and circle, the height function is different, and the what is different, and the show is different. So and the constructor is different, and the destructor is different. Okay, so the constructor is numeric, but the destructor may be different. So instead of this, it is possible to put here some other information, okay, some other actions. Okay, so what does it mean? It means that the names are the same, but the destructor has a different name. It is not about the destructor. It is only about the same names. So the variables are the same, and height, show, and move are the same. Okay, so these are height, move, and show from my point, from the C point, and this height, move, and show from C circle. Okay, this is x from the point, x from the circle. Okay, so but the names are the same. So here, if we put dot, so we have the list C, X, Y, C, R, hide, move, show. Yes, hide, move, show. Yes, and let us put dot here after my circle. So again, X, Y, R, C, hide, move, and show. Yes, the same names. So this is polymorphism. So the names are the same, but the purposes. So here circle, here point are the actions are different. Okay. So here is x for the point, so 25 now, and here x is 46. If we return here my point, so x turn to 25, not 46, but 25 like here, so it does not change after the move. Okay, and after the creation 43. Okay, so it means that the names are the same, but the functions are different. with, okay, so how to understand that this function height is from the class C point. So here the object of class C point is placed. So it is not now height, it is height my point, for example. It is not Samir, but Samir which Samir? Samir fit V. Samir fit V. For example, other Samir. Samir not fit V. For example, this is Samir too, but not fit V. For example, yes. For example, this is Nikolai, my name, but Nikolai Ulyanov, my surname. This is Nikolai too, but Nikolai Vladimirov, for example, other Nikolai. Okay, so this is so-called, we can call this the extended name. Okay, so yes, the name of the function and the name of the object of the class, not only indicated. Okay, so this is a principle, second principle, polymorphism. Polymorphism, that the same functions, the same variables can be performed in many forms. So how much forms? In two forms now in this function height, in the form of the class of the member of class C point, this function height is performed in the form of the form of the class my circle, but the same name. So the move from the class C in the form my point or the class C point, the move in the form of class C circle. Yes, this show in the form of class C circle, this show in the form of class C point, this x in the form of class C point, this x in the form of class C circle, y C R 2, so y in the form of class C point, y in the form of class C circle, yes, yes, R in the form of class C point, so here R in the form of class C circle, here C in the form of class C point, so here C in the form of class C circle, yes, the polymorphism. Okay, so this is so-called polymorphism of methods, but we see that not methods, but polymorphism of variables of fields too. Polymorphism of fields and polymorphism of methods. Okay, but this polymorphism of methods, this is a partial polymorphism, partial polymorphism. We have the polymorphism of objects. So now it is not seen because we have this object is the object of my point, but this object is the object of my circle, Okay, so but in more complicated programs, so it is possible to continue. For example, my point from other, for example, geometry. Yes, if we create, okay, so, and it is possible, for example, to create my point from trigonometry, for example, my point from trigonometry. I'm sorry. Okay, so in very wide projects, okay, so we have, like in Russian, familia, имя, отчество, not only the name of first name, not only the last name, but the name of father too. Okay, yes, because father has a brother, okay, so the surname is the same, but different fathers, okay, so different persons, okay. So in this case, this my point object is the object created in geometry, in some geometry others place of memory. So this my point is different my point. This is an object created in the place of memory trigonometry. Okay, so this object my point and this object my point are two different objects. So this is the complete polymorphism, the polymorphism of objects, but it is not present now in this program. In this program only is presented the polymorphism partial, the polymorphism of members, it is better to say, the polymorphism of methods and polymorphism of fields. Okay, this is partial polymorphism, but it is possible to consider the total polymorphism, the polymorphism of objects. So it is possible to create even the object with the same names, but in different places of memory. So, but it is in the cases of very wide programming, very wide programming. Okay, so it is not necessary to give you now the example of these cases. Yes, so it is only now possible to explain. For example, this object is created statically. Yes, so we use the point operator. For example, trigonometry may be created dynamically. So in the case to obtain statical object created in the trigonometry, so it is possible to use this. For example, yes, so the place of memory trigonometry was created dynamically, but my point in this place is created statically and height from this statical object from dynamical object trigonometry. So this is possible to use too. So it means that this was created dynamically, this was created statically. So this is possible too. But if I show you the modern Microsoft .NET framework, .NET framework, okay, so to show you, so you will have some horror. Okay, so now let us return to the internet and I will open you the so-called C# or C++, CLL, .NET, for example, namespaces of .NET, okay, namespaces, let us open namespaces. Okay, namespaces, where namespaces, no, namespaces, okay, so not here, it is better to show you some of my projects, okay, so let me show you some of my projects, namespaces and some of my projects. So the modern very wide libraries. Okay, so for example, Android is the same, Java is the same. How it goes? So here we have only name with two parts. So I shown you the shown you the name with 3 parts, but how in our modern libraries of programming it appears. Okay, so let me show you. Okay, so let us open some. Okay, maybe projects, but which projects? My projects. No, not this. My projects. Maybe my projects 1. Window, not window. It is bad idea. So my projects. Maybe my project, but which my projects? Not here. Okay, now let me open the disk. Yes, I remind. Okay, so let me open. Okay, let me open. Okay, okay. So what is necessary to open? Maybe this. Okay, let us try to open. Okay. Okay, do you see this horror? So system, Windows, forms from Windows, Windows from system. Okay, so this is so-called namespaces of C sharp, namespaces of C sharp, even not C sharp, C++, CLI. This is typical for Java, So very wide libraries. So it is not only some class form, but from namespace forms, from namespace windows, namespaces, the term namespaces is used, from system Windows forms. Yes, do you see the class form public from the class form from the namespace system Windows forms? Yes, so very wide library. So modern programming, C sharp, so the .NET framework, or in Java, so the same situation. Okay. So let us go. Okay, we have only hide function from my point class. Yes, so this is a polymorphism. So the same members may be in the object, but the same object may be in different namespaces, okay, different classes. For example, the class cPoint from namespace geometry, and the class cPoint, the same class with this, but from different namespace, from namespace trigonometry. Okay. Very well. Okay, so let us again end. Okay, so let us sure and let us press any key to continue. This is only point on and point off. So in this way it is possible to continue with the to add here this my circle, yes. Yes, to messages about circle and 2 messages about point. 2 messages about point hide and show, 2 messages hide and show about circle. Okay, let us see the result. Yes. So between points will appear circles. Point of circle, circle of, yes, point on circle on 100 steps. Okay, so yes, the emulation in textual mode of the motion of the point and the motion of the circle. So it is possible to add in this hierarchy the third class, for example, the class of the square. Okay, see circle squared, for example, to continue the hierarchy. The top of the hierarchy, the basic class C point. The second class of hierarchy, this is so-called son. This is the father, and this is the son, or this is the mother and the circle, I'm sorry. This is a daughter, for example. But maybe grandfather, son, and grandson, or how it going in English. Okay. Okay, the hierarchy of 2 classes, so it is possible to add here after this one more class, okay, and to continue this hierarchy. Okay, so the situation will be the same. It is not necessary to heritage the fields and the move function. Only the virtual function must repeat it anytime. If in basic class some functions are virtual, so it must be placed in all the classes of hierarchy. Yes. Okay, so this is the end of our lesson. So after this, I will put this information into the model. I will put here the recording. Yes, I'm sorry. Okay, so very hard day. Yes, so and it is all for today. The students of 211 group. So wish you good health. Please wear masks. Yes, wish you good health. Be careful, please. So and that's all for today. See you next time. So next hour time. So I remind you that today is 13th of November 2020. So the next time, today is Friday. So the week, the educational academic week is over. Okay, so and the next week, Tuesday, the 17th of November 2012. So the fourth lesson again, we will have laboratory work. So in this laboratory work, I suppose that we will compile all these C++ projects in online GDB. So not to give you possibility to see that all executed files are not Trojan files. So you may decide that this Microsoft Visual C++ 6.0 generates the Trojan exe file. No, it is not true. So we can compile in internet these programs, and we may obtain the result in internet with no indications that this is a Trojan program. Okay, so let me stop now the record. Okay, see you next time, and it is all for today. Yes, see you next time. The record is over.